Okay. Morning, everyone. Sorry, I was having a little mic battery issue. Should be good though. Anybody have any pressing questions before we start? All right. I'm super. Well, that's a lot. I'm stoked that you're all here on this spring break eve. Or I guess it's actually spring break? I actually don't know. Is it after your classes are done? Okay. So, what we're trying to learn is, oh, I'm back a little bit. Okay. We want to try to understand pointer semantics, right? We want to understand what exactly are these pointer operations and what do they do, right? So we looked at both pointer dereference and the address of operator, and we saw how we can use circle box diagrams, which are really simple, to show and illustrate how these semantics work. So let's look at a more complicated example. So can everybody read that? So I've got an int star star called x. I have an int star called y. I have an int called z. And then I'm going to call malloc size of an int pointer and assign that to x. I'm going to assign y the return value of malloc of size of an int. I'm going to set x equal to address of y equal to address of z, y equals star x. Okay, so we're going to step through this line by line and try to see what actually happens. So we should, before we actually show what happens, we should talk about it so that we can predict and know exactly what it should be. So this first line, so what's going to happen in like the box circle diagrams after this line is executed? So if you're doing this, right, you're going through, you say, okay, I want to use box circle diagrams to understand what's going on here. What do I do? Yeah.
You'll just have a location x at that point in time.
What x?
A location that x is assigned to or maps to. I can't remember the exact language.
Bound to. Yeah,
yes.
You figured Kanye West. Bound. Okay. So if x bound to some location. So the important point is it's some location, right? And we don't know the value that's inside that location that's bound to x. Right? At this point, we have no idea what's in there. Okay, and then this line? Same thing with y. We just have a new name and a new location. Here is z, same thing. Right? So, important point here. So what's the difference between, in the box circle diagrams, all three of these values, these names, x, y, and z? The types? Yeah, but in the diagram, what's the difference? Nothing, right? This is one of those fundamental concepts that you have to somehow inject into your brain or jack into the matrix and learn it, or struggle with it for a while until you realize pointers, double pointers, int star stars, right? No different than any other data type. It's just what's inside them can have a different meaning depending on if you do if you do the dereference operator.
So even if it's a non-primitive type, it's the same?
Even if it is, say that again?
A non-primitive type, it's the same idea?
Yeah.
Okay.
Yeah, so you mean for if this was struct,
Yeah.
struct foo z?
Yeah.
Yeah, so it would just mean that what's inside here, because here we're abstracting away the exact number of bytes that's inside each of these values, so technically there'd probably be more bytes, but we don't really have to worry about that. But the value where that struct is going to live is in a location that's associated with that name.
Okay.
Exactly. Okay. So when we get to this line, right? So what's malloc? What does malloc do at kind of a high level?
It returns the address of freeze memory.
Yes. So it returns the address of what in the box circle diagrams?
The location, the box.
The address of what box? Of this box? This box? This box?
Okay, so
This box?
it will be the box.
Let's let someone else answer.
Okay.
A new box?
A new box. Yeah. So abstractly, right, in this circle box thing, we just need to know that malloc is going to create a new box, right? And we know that the size of whatever can be inside this new box is what's given at the parameter, right? That parameter is exactly how many number of bytes is going to be inside this circle. But for our purposes, we don't care about that when we're just talking about here with box circle diagrams about who points to what and how do we access things. So we'll say that this has an address of 4, hex 4. I'm going to write it in kind of hex like this, so it's pretty clear that that's an address. So malloc does this, right? Creates this brand new location for us at some memory location, and then it returns that memory location, right, with a R value of 4. And then what happens what is this whole assignment statement going to do?
X now points, or X is now bound to that new location.
Ooh, X is bound to the new location? How would the diagram change if that was the case? So this would be, let's see if I can do this with this terrible thing. This is going to fail. But we'll try this, right? This would mean that this name X is now bound to this location.
Points to it.
The value inside of X now has that memory location.
Yeah, so the value, right, so this is the way to break it down. This is why we kind of built it up into little steps, right? So we know the exact semantics between L value equals R value. So here on the left is X an L value or an R value? L value. Yeah, there's a location here associated with X. And so malloc returns an R value, which is 4, the address of this new memory location. And so then if we have L value is equal to some R value, 4, what do we do?
Store it in the value associated with your L value.
Yeah, just take, exactly. That's good semantics. So take the 4, store it in the location associated with the name X, right? And so that's going to be 4. So so where does now, is there any way I could erase this red line? Reset? I don't know. I wonder if I just like move it, will it go away? Yeah, success. Restart, fixes everything. Okay, so now that this 4 is inside the value associated with X, if I were to do star X, where does that point to now?
4.
4? So it points to here?
The value inside of there.
The value inside of here?
Yes.
So star X is going to point to the circle? What does the dereference operator return? Does it return a value or a location? A location. So what's it going to point to?
4.
The location that X is associated with, so whatever it is.
The location that star X is going to point like here?
Yeah, it'll do that.
The box at 4.
Yes. The box at 4, right? So specifically, star X is going to point to the box, right? And this is why, so the dereference operator is a location, right? So this is exactly why we can use this on the left-hand side of an equation and to be able to write to it. We can access the value in here. If we use star X on the right-hand side of an equation, right, it's going to get the value associated with the location star X. And so it's going to be able to get that value out of there. But we can use it on the left-hand side because it specifically points to the box. So it looks up 4 and it says, okay, give me the location associated with the memory address 4. Yeah. Oh, it probably died. Okay. Well, we're running out of options because there's now 2 dead batteries and 1 half dead, 3/4 dead battery. But let's try. It's awesome when people put batteries in a container marked new that are actually old. I haven't yet got to the case where I'm lugging around batteries in my bag, but I'm sure I'll get there at some point. I have markers in there too, just in case. Ready to teach at a moment's notice. Okay, so is that everything that's done now in the semantics here?
Yes.
Yeah, right? We've taken that value, we've assigned it there. Right, so remember, so this star x doesn't actually, right, we haven't used that in the program yet, but you can see that this is where star x points to, right? And because this is semantics, and because it matters a lot, right, if you're, you know, you have to be precisely correct in these things. So on a midterm or something, if we're like, okay, draw the circle box diagrams at this point in the program and label like star x, right? If you draw star x going to the circle, it's not correct, right? Star x points to the location because it's an L value. Okay, so then what's going to happen here on this y?
New memory address.
New memory. So Malik's going to create a new memory, so how am I going to draw that?
New box insert.
New box. Yes, so we get a new box. It's going to be some memory address. We'll call it location 8. We'll consider that it's 4 bytes away, but really, right, these could be completely abstracted. They could be whatever. It doesn't really matter except that it's different from those other addresses, right? And then what's going to happen after malloc creates this value?
8 goes into the location associated with y.
Yes, so 8 is going to be copied into the location associated with y, and now where does star y point to?
Box at 8.
Yeah, the box at the memory address 8. This is all pointers are. And then, are we done with this line? Semantics?
Yes.
Yes, it's a 50-50 question, so might as well. Yes. Yes. Okay. Now, what's this line going to do?
Change the value inside of x.
Change the value inside the location associated with x? Yeah. To what? To 8?
No,
No.
to y's address.
To y's address. Yeah, so we actually haven't given, we'll just give them addresses, the address of x, the address of y, the address of z. It doesn't matter how you do this, right? On a midterm or something, we'll usually tell you, assume x is at some memory address alpha, or address of x is usually actually a super easy way to do it. So now that we've given them these names, then what's going to happen? What are we going to do? So what does the address of y return?
The box.
ADY. Yeah, remember, address of operator returns an R value. So it takes in a box, right? It takes in a location, and it gives you the address, which is an R value associated with that location. So it's going to return the address of y, and then that's just some value. So where's it going to put that value?
Circle and x.
Yeah, in the circle in x. So now where does star x point to?
The box of y.
The box that also has the name y, right? So now it's going to point here. So what happened to the location of the memory associated at 4? Did we touch that or change that?
It's leaking.
It's leaking.
Yes.
So why is it leaking?
Because we didn't free it.
It's not the-
Right, so a key problem, well, we're going to get into it in a second, but this kind of is foreshadowing, right? So is there any way we can reference this location 4 now? Maybe. I mean, we can iterate through over all possible memory locations, right? But, you know, semantically from here, there's no way. So in our program, right, we can only access X, Y, and Z, the names X, Y, and Z, right? And then from there, we can access their dereferences, right? So we can dereference any of those pointers. So we can go to anything they point to. And we can go to anything those things point to. But how do we get from X, Y, and Z to star 4? The location at the memory address 4.
Magic.
You don't?
We can't. Yeah. So this is basically a memory leak. The problem is, or it's, it's a, trying to remember the exact term we use. We'll see it in a second, but it's essentially a memory leak. So we have created some memory, right, that can no longer be accessed by our program. So how do we access this OX8?
Through y star.
Star.
So we can use y, and then we can do y star,
Or
right?
star
And so that'll
star
get us
is-
there. or star star x. Yeah, so we can go x and then star star x to get here. So that's fine, but 4 we can never reach. But let's continue executing. We'll kind of set that aside by now. Okay, we get to this line. Y is equal to the address of z. So what's going to happen here?
You lose access to one memory.
Yeah, so what's the address of z?
ADZ.
ADZ. And so that's an L value or an R value?
R.
R value. Yeah. So it's an address, it's just some value. And so we're going to copy that value where?
Circle of Y.
The circle and the location associated with Y. So we take that, we're going to erase that. And so what's going to happen to star Y?
Points to Z.
It's going to point to the location associated with Z. Yeah, right? Remember, so star Y is now going to point to the box Z. So what's going to happen here?
The value of ADZ is going to equal to, or is going to be changed to the value of ADZ.
Yes. Okay. So let's break it down. So star X, what's that going to return, an L value or an R value?
R value. L.
L, always L. Stars, dereferences, always L. 50-50 shot. Always L, right? That's why it points to this whole box, right? So star X is going to return this box. And so we have an L value, right? Y has a location associated with it. And on the right-hand side of that assignment operator, we also have an L value, right? A location. So take the value inside star Y, which is ADZ, copy it into the value of the location associated with Y, which is this box. And so we copy ADZ and put it back into ADZ. Questions on what happened here?
Can you explain that again? Yeah.
So which box is star X? What's the value inside the box of star X?
ADZ.
Right? Because star X means take X, take the value inside of X, look up that, find me a box with the address of ADY. So which is the box here with the address of ADY?
Y.
Not Y, Y is a name. The location associated with Y, right? So it's this box. So star X is going to refer to this location. So we have basically the location associated with Y, assign that whatever is in the location associated with star X. So star X, we get the value in that location, which is, what's the value in the location star X?
ADZ.
ADZ. We take ADZ, where are we copying it?
To the location associated with Y.
Yes, into the location associated with Y. So this is the location associated with Y, and the value, and so we copy ADZ into there, and in effect, nothing changes. Does that make sense? But yeah, we have to know, to know that nothing actually changes, right, we'd have to know that X is the address of Y, or X has the address of Y, so that when we dereference X, we're talking about that same location. And this is why pointers make analyzing C code very difficult, because there can be multiple ways you can reference something. So if I want to ask the question in my analysis, hey, is it ever the case that this value could be 0? Well, if the value inside Y could ever be 0, well, it could be 0 if you set Y equal to 0, which is easy to tell. But is there any possible way that all pointers that point to Y, did they ever change their value to 0? So it becomes very difficult. Okay. Then let's add on to this program, make it a little bit more complicated. Let's set Z equal to 10. So what's this going to do?
10 in the circle for Z's location associated with Z.
Yes. Take 10, copy 10's an R value, copy it into the location, the value of the location associated with Z, which is right here. We're going to put 10 in there. And we're going to print out star star X. So where does star x, what does star x refer to?
The location associated with y.
Yeah, the location that has the address of y, right, which is this box. And then what is the star of this box?
The location associated with z.
Yeah, so you take the address of z, right, the value in here, look up the location associated with it, and it's here. And so when we print it out, we're accessing the value in star x star, or star x, right? One dereference and then dereference this location, so we get this location. And so we print out 10. Does that make sense? Then we say star y equals 100. So how do we get star y? How do we figure it out?
You go to the location associated with y, then you take the data that it points to, use that as an address, look up that location.
Not the data that it points to. The value that's inside the location associated with y, right? So that's because I want to. When we say what y points to, we would say this, right? So y is a location, right? Has a location associated with it. There is a value inside of there. So when we do star y, should be star y. That should be switched. We're going to look up the value in. I should go fix that now, otherwise I'll never forget, or I'll never remember. Okay. So we're going to get this, the value in the location associated with y, ADZ. Then look up, are there any locations with the address ADZ?
No.
Yes, this one, right? This location. And so we're setting, so this is the L value, and on the right-hand side we have 100. So we're copying 100 into this location. So we just take 100 and put it where? In the circle here? Yeah.
How would this change if the value associated with y was like an integer instead of an address? Would it try to look up the address of the integer and do this?
Just like with the 4s and the 8s.
Okay.
Yeah, I mean, at the end of the day, we only representing this like ADZ, ADY because we're trying to say we don't know necessarily beforehand what those addresses are, but they are just integers.
Yeah.
That's the important thing.
So it could look up invalid memory
Exactly.
locations.
Yes. Yes. And that's how you get into problems. But that's all first. Yay. Bad code makes me angry. Okay. So we're going to copy 100 into here, right? Into location associated with star y. And then when we print out z, what's it going to print out? 100. Yay. So we kind of saw it here. So why when I changed star y, why did z change?
Because the value associated with the location of y contains the address of z.
Okay. Yes. And what does that, so star y, right? The expression star y and z, what do they both refer to?
A memory address box.
An address, the box, yeah, location, right? So yeah, they both refer to the exact same location. So that's another way to think about it, right? Is z refers to this, z is bound to this memory location, and star y references that same location. What about star x?
Same thing.
Yeah, it's actually another name for this location, right? So what we call these aliases. So this means that they are different names for the same location. So an alias is, two L values, so two different names, two different L values that have the same location. Right? So at the end of execution, so what are all the aliases here? If I asked you on on a test or a midterm, we said, okay, here's a program at this point, draw the box circle diagrams, what are the aliases at this point? And then what are the aliases at the end? So at the end of program execution, what are all the aliases here? We'll do pairs of them.
For X, X,
For X, wait, what's the alias for X?
X.
That's the same name, so not as interesting. You can ignore alias, yeah, they have to be different expressions or L values, yeah.
Star X and Y.
Star X and Y. Yeah, so star X also refers to the same location. So we have star X and Y. What are the other ones? So we have Y star and Z. What was the other one we said? Star X and Z. Yeah. So these are all the same. Star X. Wow. Never know. Okay. Perfect. Okay, so let's look at the. I think there's some. What were some questions that we were talking about with this? I just thought like, hey, I should do an example after this, but I couldn't remember. Nobody remember? You have like questions on this? Yes.
If you were to do star z equals 50, does that mean it would try and go to the memory location 100 and put 50 in the value there?
Yes, that's exactly what happens. Yes. Okay, yes. So that's some other things I want to look at. So if we had a program like yeah, so if we said z equal to 100 and we said star z is equal to 50, like this. And we may need to do, if we actually wanted this to compile right, we have to cast z to an int star. So that way we're telling, because the compiler's type system says, hey, you can only dereference a pointer data type, right? But this is just an integer. But C will allow us to say, hey, I know you think this is an integer, but trust me, it's really an int pointer. And so this is exactly what it's going to do. So it will, so if we draw the box circle diagrams, we have our z, right? We have our box. The value we put inside here is 100 at this line. And then when this line executes, it's going to try to look up any memory address, some memory address that has the value 100, and then set that value equal to 50. So if we can do that, it'll actually succeed and it'll work just fine. If it doesn't, if it can't find something, then it's segfault. So this is also where you can get segmentation faults. So let's look at, actually this is a good point. I want to look at some other code. So if I had code like this, let's say I have char pointer test, always fun to do that, right? Okay, so we have a character pointer called test, and we want to say what happens when we do, well, maybe this isn't the best. Can we change that? I think it's in read-only memory. Maybe we can write to it. Let's leave it like this, whatever. It's just a simple example, we can do whatever we want. Okay. So, what actually happens here? So, are there any pointer dereferences that are happening here?
Explicitly no, but an array access is very similar.
Is it very similar? How similar is it?
It's the same.
Test is still a pointer, so it's still just a pointer to it.
Yeah, so did you know you can write your array accesses like this?
Strange.
Do you believe me? Ooh. Let's write some code. Alright, I wasn't planning on doing this. always fun to do coding exercises live. Test.c, pound include, we need to be able to look at things, so we want standard io.h. Code up int main, what I say, character pointer test is equal to something like this. And what I say, test 0 is equal to A, test 5 is equal to B, test, or no, 3, C. So we'll print out the string first, %s, test, %s. So what's the %s in the printf doing?
Print out a string.
Prints out a string?
Yes. Character
Hopefully.
array.
Alright. So let's see what happens. Alright, we're gonna not use, is everybody okay with us not using CentOS for this and using the Mac compiler? If it's valid C code, it should be the same, right? And of course, I say that, it's gonna all blow up in my face. Successfully compiles. What's gonna happen when we run it? What's the output gonna be?
CSE 340.
The string and then the modified string.
And then the modified string.
Yes.
So it's gonna be AS, I can't actually tell. ASE C3B exclamation point. Does everybody agree? Is it gonna crash? Could crash. I actually don't know 100% what's gonna happen, but this is why programming is fun. The only thing I'm worried about is this string, because it's a constant string, I don't know if it stores it in read-only memory. So I don't know if altering that, but I actually don't. Maybe it stores it as a kind of a global string. Yeah, it should be fine. Alright, let's run it. Nope. Interesting. Okay, so when you get this, right, this is when you want to make sure that it actually does it on the right thing.
Why
Some-
is it 3 tests?
Huh?
In code you have 3 tests.
Yes. So I'm making a point.
Oh, okay.
I just haven't made it yet. Okay.
Yeah, he was saying that you could do that. So please code again.
Oh, it's slash temp. Shoot. There we go. Okay, compile. Run. Segmentation fault. So it did put it in there. Ah, tricky. We all learned something today. I think. Let's check. Just to make sure that there wasn't something like that. Oh, still a segmentation fault.
Can you, when you initialize a character array using quotations, can you still access it?
That's what I'm thinking. No, I'm thinking it's.
So you had to do it with the curly braces and
String.h, and then we can do it quick. We'll just duplicate the string, so string dupe will return as a copy of the string, and then we should be able to do whatever we want to. Is this gonna work?
Hopefully.
Is string dupe in string.io or string.h? How would I find out if I want to know what header file defines string dupe?
Google it.
Google it. Way quicker way. Look, I have to like go all the way to Google, and I don't even have my browser open. I don't want to show my browser to you guys because it's weird. All of your beautiful Linux machines comes with an entire manual that has manuals for every single function and every single bash command. So you can just do man string dupe. Look at it. It tells you exactly. Pound include string.h. It tells you all the functions. It tells you how you want to duplicate it, everything. It'll give you examples on how to use it. It'll tell you that, of course my font's big, but it'll tell you that it calls malloc to allocate the memory for the string, but that means that you have to make sure you call free. If you want to look up, what does malloc do? You call malloc and you can read all the things. You'd be like, oh, if I want to call malloc, I need to use standard lib.h. Look at this, so much faster than Google search. Hey! asec4b. Okay, that was successful. So why? So what's happening here? Let's see, can I just copy this?
I don't trust that 3.
There we go. Actually surprised that worked. Okay, so what's happening? Why did that work?
I mean, it's close to the assembly style way of doing it.
It's close to the assembly style way of doing it. So, what does my box circle diagram look at this line for test? What does test look like?
A constant string is assigned to a new memory location, and then
So, test.
the test
Sorry.
gets its own box.
Bound to a box.
Yes, test is bound to some location. Do we know the location?
Nope.
No, we don't really care. We'll call it alpha for now. What's the value inside test?
Nothing yet. Well,
Nothing yet. Let's say before this
Before
assignment
the-
operator happens, right?
yes.
So there's something in there. We don't know exactly what it is, right? And so CSE 340 is going to be stored somewhere, right? Ah. Right, that's going to be at maybe location beta. And what is string dupe going to do?
Copy it to a location. You can
Copy to a
modify.
new location. Yeah, exactly. So it's going to copy that whole string. So it's going to create a new location with enough. So this is, oh, I'm running out of Greek letters. What's after beta?
Gamma.
Anybody Greek? Yeah, what does gamma look like? Is it? Oh, that's right. Okay. Yeah, I have to look at it all again.
Just try cat.
It's an upside down. We'll.
Let's do lambdas.
Lambda is good. It's going to get confusing when we get to lambda calculus stuff. Okay. So, we have CSE 340 exclamation point, and technically there's actually a 0 byte here, right at the end, because C style null terminated strings. So there'll be a 0 byte there. So, okay, then what, so then string dupe is going to create that and return lambda. And so what does this assignment do?
It assigns the circle to lambda.
Yeah, which circle? There's 3
The
circles
test
here.
one.
Yeah, and the, well, you want to do the whole thing?
Not really.
It's good practice. The location associated with test, we're going to copy lambda into there, right? So test has the value lambda. So where does star test point to? Which location? This one? This one?
That one.
This one?
Yes.
Okay, we'll do this. Okay. So we print it out. It's going to print out this whole string. So the %s is actually going to iterate over the string length, and it's going to print out basically test 0 as a test 0 as a character, test 1 as a character, test 2 as a character, all the way until it gets to a 0 byte. So then, how does that access work? So when I see this line specifically, test 0 is equal to A.
So
Get
the
So first, what is the array access actually doing? Do you know, what are the semantics of the array access?
it dereferences and then chooses.
Dereferences what?
The
Right
test
here.
dereferences whatever stores the location.
So can you rewrite this into equivalent valid C code that's more of what actually happens?
Yes.
So it could be
Star what?
star test plus whatever's in the square bracket.
be multiplied by something.
Size
0
of-
times something.
Size of,
Yeah, size of.
yeah.
Size
So,
of
where are the parentheses on this? Like this?
car. And
Other way. No, it's test plus 0.
Like this?
Also
Test
no.
plus
No.
0.
Parentheses begin right after the star and then end after you calculate the rest.
Yeah, so this actually, so some people were talking about size of. At the C level, you don't have to worry about that because pointer arithmetic will automatically increment the pointer the size of whatever the pointer is. So that's why if you do test plus 0, or test plus 0 is obviously test, right? Okay,
but test plus
so what is the character, what's the data type of star test?
character.
Character. Yeah, how big is a character? How many bytes?
Byte.
A single byte. How many bytes do we have in here?
I don't want to count.
1, 2, 3, 4, 5, 6, 7, 8. 8 bytes in here, right? So what's test plus 0? Doing this arithmetic, what's that going to be?
C.
Test plus 0?
It's going to be just the base
Oh,
of
sorry.
test.
Yeah.
I thought we were talking about value here.
Test
Lambda.
lambda. It's just lambda, right? So lambda, so what's star lambda then?
C.
Yeah, so it's a little bit tricky, right? Because this is actually an array of contiguous elements. So really, if we wanted to draw this more precisely, we would have lambda, the value inside there is the character C. Yeah, so what's this address?
Lambda plus 1.
Lambda plus 1 is going to have the character S, and lambda plus 2 is going to have the character E, and so on all the way through, right? So the location of lambda is actually this guy, right? Oops, too much. Right, so star test actually points to this guy. And so we do test plus 0 is lambda, right? Because the address, the value inside the location associated with test is lambda. And then we dereference that. So we look up, okay, where is the location associated with lambda? Oh, it's here. So then I'm going to change that to be what? A, the character A, right? Which is going to be some specific bit pattern. And then in our more abstract model here, that's going to change this to be, right? Okay. So what about the next line? Test 5 is equal to B. So what's that equivalent to?
Lambda plus 5. Or test plus 5.
Yeah, star test plus 5. So test plus 5 is
Lambda plus 5.
lambda plus 5, right? So lambda plus 5 is 0, 1, 2, 3, 4, 5 here. So then we're going to set that to be what?
B.
B. So we're going to change this to be B. And now 3 test equals C. So what's that? What's 3 test equivalent to? Yeah. Star 3 plus test. Is it any different from any of these cases?
No,
No, it's exactly the same. So what's 3 plus test?
lambda plus 3.
Lambda plus 3, the value lambda plus 3. And so star lambda plus 3 is going to return that location that's associated with lambda plus 3. Lambda plus 3 is 0, 1, 2, 3 here, and it's going to set that equal to C. 0, 1, 2, 3. And now we print that out. This should be the string that we printed out, right? So this is, so specifically the array access is just syntactic sugar for doing pointer arithmetic. So it's saying like start at test, go 5 elements down, and the size that this actually moves in terms of memory depends on the size of the thing that's being pointed to. In in this case, it's characters, so it's actually just bytes. So it's going to offset it by 1, actually by 1 when it goes to the actual memory. Yeah.
So it makes sense to me where you have like the name of the array and then you have the parameter of how much to add. But why would they also give you the option of doing it the weird 3 brackets with the name of the array inside?
Just simple. So I mean, so the question is, so in this case, maybe it's clear because it's a value. But what if we had code that was like, right? I mean, then you have to kind of be more careful about who's what and all this kind of things. It's honestly just A, for probably consistency purposes and the fact that all this is a translation to this, or all that these are just merely translations for this. So that's why when I mean that it's syntactic sugar, what that means is that there's already a way to write this expression in the C language, right? This thing that you can do here, you can do just like this. But it's a little bit more cumbersome, and it doesn't quite convey exactly what you want to do. So they allow you a super easy way with like this, and they just translate between the two. Or not between, but they just translate very clearly between the two. Yeah, I mean, if they were thinking far ahead of like, oh, everyone in the world is going to be using C code and C applications, then yeah, it would have been nice to use the type system to say, no, actually, with array access, you have to have only, you know, an int or something like that in the access. But
It just looks really weird.
Yep.
So C
Still
is
valid.
C is just written such that when you have an array access where you have something with the brackets
Mhm.
and then something else in the brackets, you're just adding the two and then finding the value at that location.
Yep.
Okay.
Yep. It's exactly equivalent to this. So similarly, if I have if I have a struct, a pointer to a struct foo called test, or I'm running out of test. So we have a variable name.
Temp.
We'll go bar. Huh? Temp? What if it's not temporary though?
It is now.
Okay, so struct foo pointer malloc size of. Okay, I think that's mostly right. Right, so we're gonna create some new thing, and now when I do temp, if I do temp equals one of the, let's go bar. Right, when I do this, this is actually also syntactic sugar for start. It's actually start temp. I don't know, it's like this. Start temp dot bar. Right, because if I had a struct foo called not temp, right? I could access element bar by not temp dot bar, right? Is equal to 10. So this arrow access is just syntactic sugar for this. So it does automatic translation for dereference the thing on the left and then turn it into a structure access for the thing on the right. This is all this does. And then you can combine them together, right? So you can be like array I baz, and that'll be something like array plus I, so this be star of that, and then take that whole thing, or dereference, let's see,
Shouldn't
Yeah.
it be
dereference that whole thing, right? And then call access structure bad, right? So this actually has two pointer dereferences, right? So array is going to be a pointer to an array, a pointer of structures. Does this make sense? Cool. All right. I think we've covered a lot today. I'm actually super happy. Cool. All right. Have a good spring break. See you on next Monday, not this coming Monday.